Hey everyone, welcome back to Neural and Wires. So, in today's video, we're diving into a key mathematical trick that helps AI focus on important information, which is a weighted aggregation. Sounds complex, but don't worry, we'll break it down in a beginner friendly way with real world examples so you can fully understand how AI processes information. By the end of this video, you'll know how AI decides which information is important, uses matrix multiplication to speed up calculations, and lays the foundation for self-attention in transformers. So let's get started. So guys, what is weighted aggregation? So before we dive into code, let's understand the concept with an analogy. So it's an analogy. Imagine you're studying with a group of friends before an exam. So each friend shares a summary of a different topics, but you don't listen to everyone equally. So you pay more attention to your top performing friend, but you still consider others' input, but their importance fades as they go further back in the discussion. This is exactly what AI does. It assigns different importance. It assigns different weights to past information before making a decision. Now let's see how we can implement this idea into code. So step 2, let's create a simple weighted aggregation model. First, we set up a toy example to illustrate how matrix multiplication helps combine past information. So step 1 here is we create a lower triangular matrix only considers past information here. And step 2, we normalize each row so weights sum to 1. Step 3, we create some sample data like test scores of a students. Step 4, we multiply weights with the data to compute weighted sum. And step 5, we print results, right? So step 3, let's understand the code. Now let's break it down step by step. Step 1, we create a lower triangular matrix, right? So right here we create a lower triangular matrix. This creates a lower triangular matrix, meaning that each row only considers past values, like remembering what was just said in a conversation. So analogy, this is like a student taking notes in class, right? So row 1 only remembers their own words, row 2 remembers their own words plus what the previous student said, and row 3 remembers everything from previous student. So let's step 2, normalize the weights. This ensures that each row sums to 1, so it works like a weighted average, right? So, and step 3, we create a sample data. This generates the random numbers that represent our data set, like scores or words in a sentence. And step 4, we compute weighted aggregation. This multiplies our weights with our data, just like averaging past experiences. So on step 4, let's scale up to a more complex example. So in real AI models, we don't just use 3 rows, we might have millions of sequences. Like, let's look at how we can apply this to a larger data set. So this is a batch size, time, steps, and channel size, a random data, and we initialize the result tensor. So we compute the cumulative average using a loop here, and this one we consider all previous elements and we compute the average. This code mimics how transformers process language, but loops are slow. So instead of, we use matrix multiplication to speed things up. So here we have a lower triangular matrix, and we normalize weighted sum, and we check the accuracy. Now we optimize our AI to process sequences efficiently. So what's next? Now that we already understand the weighted aggregation, and we're ready to introduce self-attention for more advanced AI learning, and learn how AI decides which words are important, and we will build towards transformers and GPT. So if you found this helpful, hit the like button and subscribe to Neural and Wires and comment below. So guys, what was your favorite AI concept so far? Alright, I'll see you in the next episode where we take our AI model to the next level.